Hello, I'm Dr. Winquist, your guide in this tutorial. The SKF Global Application Engineering and its Engineering Knowledge Competence Center team presents a video on tapered roller bearing rundown effect. The first video explains the rundown effect in tapered roller bearings. We will first explain why it is necessary to rotate the bearing before taking axial clearance measurements, and then demonstrate a simple, practical way to illustrate the importance of rotating the bearing to obtain the correct clearance measurement. We will finish with the case of vertical shaft. Let's first explain the rundown effect. When a tapered roller bearing is assembled, the roller isn't, with some rare exception in its operating position against the guiding flange. If the bearing is loaded, the roller and inner ring contact load and the roller and outer ring contact load are not aligned as the roller has a tapered profile. It creates a force that pushes the roller upwards against the guiding flange. However, friction forces in the roller ring contact, red and white arrows, counteracts in opposite direction. Due to taper angle, load, inner and outer ring alignment, and coefficient of friction between roller and raceways, in standstill conditions, the roller doesn't move towards the guiding flange. The rollers will start to move upwards against the guiding flange only if they rotate. Depending on the bearing internal design, the load and the lubricant in the bearing at assembly, there is a need, on average, to have 10 to 20 full bearing rotation turns under load before the rollers reach their operating position against the guiding flange. If the bearing is not rotated during adjustment, the desired clearance or preload may not actually be achieved. The clearance will increase or the preload will decrease as soon as the machine is put in operation. Let's recap what was said about the rundown effect. After assembling cup and cone, the rollers are rarely in their position against the guiding flange. The bearing needs to be rotated so that rollers move towards the guiding flange and find their operating position against the guiding flange. On average, it takes 10 to 20 full rotations for all the rollers to find their correct operating positions. Before any axial clearance measurement, bearings should be rotated. If not, the measured clearance is likely to be lower than the real clearance. Now, Philip will show the rundown effect with real bearings. Let's pay attention.
I'm Philip Guéchet, and today we're going to talk about the need of rotating the bearings, the tapered roller bearings, when you want to do the adjustment of clearance or preload. For that, we're going to use the input shaft of the gearbox and two TRB mounted back to back. Let's mount them in the housing. Now that it is mounted, we will check the axial clearance with the push-pull method, meaning I push in one direction and then I pull in the other direction. And to measure the axial clearance, I will add a dial gauge. Now, to do the measurement, we need to rotate the shaft several times so that the rollers move up to the bigger flange of the inner ring. But you see here that there is a hole. I cannot put my dial gauge here, so it's not exactly on the axis. When I rotate, you see that the needle moves. So I need a reference, and this reference I will use, for example, a white pen. So let's use a white pen. Let's do the marking. And now we are between 30 and 20. If we rotate, see there's quite some movement for the needle. And when we come back, we're about back in the position. This is important because when you do the push-pull, you always do some angular movement, and this can change the reading. Now that we have done the marking, let me show you how important is the position of the rollers on the raceway, the axial position of the rollers on the raceway. Let's look at what clearance we have now. Push, well, pull, push, pull, push. Okay. And I will now push all the rollers against the smaller flange. Let's do it the other side. You see now that the clearance, there's no more clearance at all, in fact. You can push, pull, even hard, nothing. Let's rotate now just, let's say, 2 times. 1, 2. The clearance has increased. All the rollers have moved upwards against the big flange. Okay, you mustn't do only 2 turns, but much more, at least between 10 and 20.
Did you note that during the last push-pull, the measured axial clearance decreased? The reason is that during the push-pull, one or some rollers may move away from the guiding flange. Let's again have a look. Philip has done several push-pull for tutorial reasons. To show clearly the difference between the two extremes, no clearance measured and clearance just after 2 rotations of the shaft. During the second push-pull, if you observe a reduction in axial clearance, double-check, rotate the shaft again. In fact, rotation should be done before any double-check. Let's recap what we have seen during the practical demonstration. Before any measurement, mark the shaft angular position relative to the dial gauge, as it isn't always possible to place the dial gauge in the exact axis of rotation. This means that any shaft angular movement will change the reading of the dial gauge, as the reference surface is not perfectly flat and perpendicular to the axis of rotation. During a push-pull movement, there is always a risk that the shaft rotates a bit and induces measurement error. With a bearing assembly having axial clearance, Philip has, for educational purposes, pushed the rollers away from the guiding flange so that no axial measurement could be measured. Even if the rollers have a tapered profile, they do not move towards the guiding flange under load. Philip has done strong push-pulls without any axial clearance measured. To make rollers move towards the guiding flange, the bearing must rotate. In case of vertical shaft, Philip will show its specificity.
If the shaft is in the vertical position, the rollers and the cage tend to move downwards due to the gravity. So on the lower bearing, the bearings are mounted back to back, the rollers fall down against the big flange or guiding flange. On the top, the rollers want to move away from the guiding flange. So when you want to do the push-pull to check the clearance in the bearing, as soon as you lift the shaft, the rollers will fall, move away from the guiding flange, and you will not have the correct clearance if you do the push-pull several times. You must then leave this bearing with the weight of the shaft, rotate it so the rollers get against the guiding ring, and then you lift the shaft so you can measure the clearance. But you cannot move it back down and up. The clearance will not be correct at the second measurement. Always try to do the measurement with the push-pull with the shaft that is horizontal.
Vertical shaft case. Let's recap. If the guiding flange is above the rollers will drop away from the guiding flange as soon as there is some clearance in the bearing. Measuring procedure must be adapted to the application and bearing assembly. As example, if the pinion shaft shown in the video with two back-to-back TRB was vertical, the shaft would be first lifted and rotated so that rollers on the bottom bearing are against the guiding flange. Then the shaft would be lowered down and rotated again so that the rollers of the top bearing get against their guiding flange. Axial clearance would then be measured when shaft is lifted again. Always do axial clearance measurements with the shaft being horizontal if possible. As conclusion of the tutorial, the main learning to remember is always rotate tapered roller bearings before any axial clearance measurement.
So I hope that this demonstration has helped you to understand the importance of the rundown effect. Don't be afraid of seeing the needle being so unstable. This dial gauge measures the micron. Next tutorial will be about adjusting the preload by the angle of the nut, tightening angle of the nut. So, see you in the next tutorial.
Thank you for your time. Let's meet in the next tutorial.